Hello everyone, welcome back to another lecture on the course Python Fundamentals, Building Blocks for Aspiring Developers. We will start with the 8th module that is about modules and packages in Python. This is our agenda. Today we will have a look at importing modules and exploring the Python standard library. Then we'll have a look at the packages and how to install third-party packages. Then we'll try and see how we can install and create our own packages and work with virtual environments. And then we'll see why and how we use packages and modules in projects. So let's begin. So modules. So as we've been working in the past lectures and modules, we see that Python promotes a lot of code reusability and maintainability. We have seen a lot of things that make the code much more modular. For example, classes, object-oriented programming, functions, these sort of things. So on the same thought that Python promotes reusability and maintainability, um, there are modules. So modules are self-contained units that can be imported in our program, so we can use some of the functionality. So it's like pieces of code that is already written that are doing some functionality. We can import that code, import those functions in our code so we can use those. We use the import keyword to access a module. So now the question arises, why do we need modules? So sometimes there exists already a pre-built piece of code, like there's a small algorithm and someone has created that algorithm and we want to use that. So instead of writing that algorithm on our own, which means that writing the code on our own, we can simply use that module. This way, we avoid writing our code ourselves, and this can save us a lot of time and effort and resources. And sometimes we want to use a functionality that is very complex to code. For example, there's some mathematical models. Being a computer programmer, it is sometimes difficult to be able to understand the models in the depth that we are actually able to create a very efficient model in coding in Python. I mean, we can know what the model is doing. We know how to use the model, but we are more concerned about using the model instead of creating the model. So, to avoid creating the model, we use some packages that offer the functionality of a model. Now, there are two terminologies that we have, that is module and packages. So, these are sometimes used interchangeably, but still they have a bit of different meaning and we need to understand that. So module is a single Python file that has a code that we can use in another program, while a package is a collection of modules. Like there could be 5, 6 modules and those together make one complete package. Okay. So there are different ways to import a module. For example, we can simply write import and then the module name. It imports the entire module. We can also import some specific functions. For example, we know that we will be only using one specific function. We can import only that function by using from module name import and then we put in the function name. And sometimes we provide an alias. That is if the module name is too big. So we don't want to write the complete name again and again when we are using that in the code. So this is why we put in alias. So it is quick for us to write it, and for that we use import module name as alias. So in the examples you can see the first one is import math. We are importing the math package, math module. And the second one is that from math import square root sqrt. So in the second line we are only able to use the sqrt function, only that one. We cannot use any other function because we have only imported that one. And the third one is that import math as m. So that is like whenever we want to use the math package, instead of writing the complete word math, we can simply write m and use the package. So we also have a Python standard library. So it is a collection of pre-built modules and packages, and it has a lot of functionality. We have already used some of that, but we will explore a bit more in this lecture. So these are already installed by default. When we install Python, we do not have to do something after installing Python. These things are already there. So let's quickly go over some of the important types of modules and packages in Python. So there's data types and data structures. So modules like collections, datetime, these offer efficient manipulation tools. Like for datetime, sometimes we have to compare date, like which is before, which is after, but there's the time difference between two dates, two times. So the datetime module offers us that. Then sometimes we have the file input output operations. We want to open a file, we want to close a close a file, we want to check if a file exists. So there are modules such as OS, IO, path clip. These then we also sometimes need networking, although we won't be exploring this one, but still, there's some networking modules that allow us to do networking tasks in our computer. Then there's threading and concurrency. That is, sometimes we have tasks which we want to do multi-threading, that is multitasking, to perform three or four things in parallel. Because up till now you've seen that Python works in sort of a chronological order, that is, it goes line by line and it does not move on to the next line until previous one is finished. So sometimes we want the tasks to run in parallel, so that is when we use threading. And other than that, there are other modules such as regular expression, mathematical operations, and interacting with the system in general. We will have a look at some of these. So let's begin with coding. So first up, let's open up VS Code, create a new file, module8.py. So let's first try and import a module that is used for mathematical calculations. So the name of the module is math. So I would simply say import math. Okay. Now we have the module math. Now we can use different functions of this module. So for example, I could say math dot add, and I can add two values, let's say 3 and 6, and I'm going to save it in a result. Then I'm going to print the result here. Save the file, run the file, and okay, it says math has no attribute add. So let's try with subtract. Okay, so apparently math does not have this one, but we can try another one. For example, let's say factorial, and we want to get a factorial of a number. So it says the factorial of 3 is 6. So factorial is like 3 multiplied by 2 multiplied by 1. So here, instead of writing the code for factorial, for example, we could have done like, we could have written a for loop for I in range 3, and then we kept on multiplying um, I with 3. So maybe we do this 1 up till 3, and we say result is equals to 1, and we say result is equals to result asterisk I. And then let's see if we've correctly coded it. Still not correctly coded because we need to make it until 4. So now we have 6. So this is what is a factorial, right? To multiply all the values up till 1, like 3 multiplied by 2 multiplied by 1 and so on. So instead of writing this algorithm, this code ourselves, we can simply use this factorial function that is available in the math module. So this is why modules are important. So for example, we also want to do a square root. So let's say I want to try and import only the square root module. I will not import this one. And I will say from math import square root. So we are simply importing the function square root. So I'm just going to print math dot square root, and then we have the square root of a number. Let's say 25. The answer should be 5. And now if I run the code, it says like, okay, yeah. So we made an error. So we just need to write square root. So when we do it like this, from module name import a function, we only need to write the name of the function. We don't need to write this math.factorial. So what this means is that factorial function is part of the math module. Okay, it does not exist without the math module. So once we import the function from the module using this syntax, we can simply use the name of the function as it is, because Python that knows that, okay, this function is from this module. So whenever I call this function, it will use the code from this module. Okay, so save the code, run the code, and we should see an error. So for this one, 5.0, right? We get a result that, okay, the square root of 25 is 5, but we get an error here. Math is not defined. That is because we have not imported the complete module. We've simply imported only one function. We can only use one function. Even if I remove this one right over here, right? Again, it says factorial is not defined. So it depends on the usage. If you just want one function, you can import it like this. But if you want to use multiple functions, let's say you can simply import complete module, not import this one. And here I would write what? Math dot square root, and here I need to write math dot factorial, and now run the code. Now it should be correct, right? So if we can use it like this, why do we need this? So sometimes importing large modules, it makes the code a bit of heavy, a bit like lagging. So we do not want that. So that is why we sometimes want only to import the functions that we are needing in the code. Now let's also have a look at the last one. So I'm saying import math as m. Okay. So this is the alias. Now wherever I want to refer to this math, I'm going to write m. Okay. So if I write here m, and here I'm just going to keep it math, and it should show us an error. So it says, okay, this one is correct, but this one is not correct because it does not recognize what math is. Because we have already given it an alias, so we cannot use this one now. We have to use this one. Okay. So I will have to make it like this, run the code to get the result. Okay. So, I mean, math is a very simple example, but sometimes you might have very long names of the modules, and then we will prefer to use a alias so we don't have to write it again and again. Also, it doesn't matter what I name it. I can name it anything. I can name it K, but I just have to make sure that I use the same alias wherever I'm using it. Okay. But having said that, it is not wrong to use, I mean, any names, but it's preferred that you use an alias that is sort of like represents the package. For example, for math, I would write M. Okay. So I know, okay, M means math. Now, just as an example, there's a package called NumPy. So we don't really import it like this. We import it like this as NP. So, I mean, it's a general practice. So whoever reads this knows that, okay, NP means NumPy. Okay. So it's kind of connected. Same reason why we use good variable names. Okay. That's one thing. So now let me get rid of this math module, and let's explore another module that we have. Or in fact, if we can also see some other functions of math that will tell us like why we want to use math. So we say print, we saw this math dot factorial, right? So we can say, okay, factorial of 4. So this is one function of the math. There's another function that is sine. Okay, that is math dot sine. Okay, and in the sine we need to give the angle in radians. So instead of converting the angle in radians, like from degrees to radians, we can simply use math dot radians and we write in the angle, let's say 45. Similarly, we can have the cosine function cos. We can also have tan, things like that. We also have exponent, so we can say math.exp 4 to the power of 2. And we can also have the values like constants like pi. So if we were to write pi, we would maybe write it to one or two decimal places, 3.14. But here it is already stored in the like in a format that is a lot of decimal places, right? So if I run the code, we shouldn't have an error. So exponential takes exactly one argument. Okay, so we need to see the documentation of this one, but still it is there anyway. So we have this one factorial of 4, we have the sine value, we have the cosine value. We can even change the angle just so it's different. Yeah. Then we have the value of pi. So this is why we have math module. We can use all these functions. Now another important module that I want to share with you guys is the OS module. So let's say import OS. So this is a module that allows us to deal with different file types, these sort of things. For example, I want to see which directory am I in. So I would say os.get current working directory. That's it. And the code. It would say, okay, this is the directory that you're in. Okay, sometimes when we want to give relative paths, we might want to use this one, right? We can also say print os.list directory. And here we want to give the directory that we have. We can give it like this. Like I can simply copy paste this one, this, like this, run the code, and it would print all the files in this directory, right? All these files are in this directory here. We can even check if a path exists. So we say os.path.exists, and here we need to write a path. So we do it like this. It says okay, it exists. Now if I change the name to code 12, name of the folder is code. Now this does not exist. So it says false. Okay. We can even check for the files. So for example, you're trying to open a file. So you say example.txt. We say example.txt, run the code. Yes, it exists. If we say example34.txt, it does not exist. So where we might want to use this, for example, in one of the previous modules, you created a sort of a mini project where you read some files. So you can first check if a file exists using this one, so you don't get into errors in the next lines of code, things like that. So this is some of the functionalities of OS module. So that was all in this lecture. In the upcoming lectures, we'll explore more about the third-party packages, modules, and custom modules. Up till then, goodbye, and we'll see you in the next one.